Flashback to September of this year. Mr. Belak is handing back the graded mechanics review test. Dave and Steve are anxious to renew their academic rivalry that had been put on hold over the summer.
Initially excited with his 149%, Steve soon finds out that Dave got 150%.
Ah! Mr. Belak begins Unit 1 by explaining that the total charge equals the number of electrons times the individual charge of an electron. Force, a familiar topic from mechanics, can be applied to electricity. It can be set equal to K times charge 1 times charge 2 over R squared. Mr. Belak continues to explain that K is a constant that is equal to 9 times 10 to the 9th. That electric field can be equal to K times Q over R squared because F equals EQ. Exhausted from his morning workout session, Mr. Belak didn't realize that he had incorrectly copied epsilon naught on the board. This all can be explained through a phenomenon called polarization. In polarization, opposite charges attract at the surfaces of different objects.
Instead of studying physics, Steve continues to dwell on the mechanics review test results. In order to avenge his embarrassment, Steve devises an elaborate plot to scare David. After studying his extensive weapons collection, he decides that his authentic Japanese katana will suffice in scaring his mortal enemy David. Sword in hand, Steve runs over to Dave's house. After kicking down the door, he approaches David's room. As a model E&M student, Dave is in his room studying physics. Upon seeing Stephen Snow in his bedroom wielding a katana, instinct takes over. He calls out,
"Come here, Mr. Pickles! No time to explain!"
As Stephen pretends to swing at him, Dave blocks the sword with his recently charged rod and...
A closer look reveals that when Dave's charged rod came in contact with Steve's authentic Japanese katana, the excess electrons transferred from the rod through the sword, giving Steve a pretty serious shock. Back at the classroom, Mr. Belak begins his unit on Gauss's law. The law states that the integral of electric field times the dot product of dA is equal to the enclosed charge over epsilon naught. As long as you pick the right Gaussian surface, this can be reduced down to E equals Q in over A epsilon naught. Gauss's law comes from a concept known as electric flux. This is equal to EA times cosine theta. Remember that you must pick the right Gaussian surface so that all field lines cross the surface orthogonally. This makes your calculations a lot easier.
Back at Dave's house, it's time for Mr. Pickles' daily exercise. But oh no! Mr. Pickles has spotted something in the bushes! Wait a second, is that an authentic Japanese ninja? Oh, never mind, it's just Stephen. After recovering from a mild scare, Dave asks Stephen why he was hiding in the bushes. Steve explains that he is actually a magician and to prove it, demonstrates some sleight of hand tricks. Because Dave is unimpressed, Stephen steps it up a notch. He daringly holds a charged rod in his hand, and because Steve is unharmed, Dave decides to touch it, and... Afterwards, clever Dave sees that Steve was wearing an insulating glove. In response to that, Steve makes a slight adjustment to the rod and proceeds to touch it with his bare hand. Scared of Steve's unfathomable power, he retreats to the safety of his bedroom.
So why was Steve safe the second time? After studying Gauss's law, he realized that the excess charges ground through Dave's hand, giving him a serious shock. But when a rod of equal and opposite charge is inserted, the electrons polarize to the inside of the rod, making the surface neutral and safe to touch. Unit 3 deals with electric potential. Mr. Belak notes that electric potential is also known as voltage, and that is set equal to the integral of electric field times the dot product of ds. To further simplify this equation, the electric potential of a point particle can be written as K Q over R. Voltage can be thought of as the work required to get a charge to a certain position, but the energy it would have there is known as electric potential energy, which is equal to QV, making the old voltage equation turn into K times Q1 times Q2 over R. It is important to note that when you deal with these types of problems, there could be three-dimensional vectors. In these circumstances, you should use partial derivatives. This is where you differentiate with respect to one variable at a time while keeping the rest constant.
Steve is paranoid because he knows about David's unquenchable thirst for vengeance. He decides to see for himself what his nemesis is up to. Using a ladder he recently bought off Craigslist from a homeless man, he climbs up to Dave's bedroom window to take a peek. In his room, Dave is curious about Steve's magic trick. He wants to replicate the trick using his own magical powers, but first he must don the sacred hat of Gandalf. Steve takes a closer look. Speculating that Steve put a charged rod in the cylinder, Dave has a short encounter with Mr. Pickles and then inserts a charged rod of his own. That rod happens to be made out of 100% red mahogany lumber. Thinking it is now safe to touch, Dave removes the glove and tests his hypothesis the only way he knows how. Laughing at Dave's incompetence, Stephen falls 2 stories off the ladder. Hearing the ruckus outside, Dave peers out the window to find Stephen Snow in his backyard. Steve yells up that the rod must be a conductor for the trick to work, but is forced to make an untimely exit.
The reason Dave was still shocked is because he used a wooden rod. Because wood is an insulator, when he charges it there is a difference in electric potential on either side. When he inserted the rod in the outer conducting shell, it only partially polarized, leaving excess charges that were still able to shock Dave. Unit 4 deals with capacitors. Overall, capacitance is set equal to charge over voltage. In terms of energy, electric potential energy of a system equals Q squared over 2C, which can be manipulated for different variables. When dealing with capacitor circuits, there are 2 types, series and parallel. In series, you take the inverse of the sum of the inverses of the capacitors, but in parallel, you simply just add them up.
This is Commander Belak, reminding you that different shaped capacitors have different equations, and you must derive them separately using geometry. With his magic career in ruins, Dave turns his attention to the ladies. Dave decides to take Maria out for some pizza.
Oh, Dave, this is a lovely pizza shop.
I know. Props to the architects who constructed this restaurant. Oh, here comes our waiter. Little did he know, Steve had ascended the culinary ladder to become the assistant sous chef of this establishment. Stephen realizes that the perfect opportunity to embarrass Dave is in front of a date. So he returns to the kitchen to whip up a quick capacitor circuit. After the capacitors are fully charged, he grabs the positive and negative ends and sneaks back to the table. After attaching them to Dave's metal chair, he returns to the kitchen and flips the switch.
Steve's circuit includes a battery and 2 capacitors. The battery separates charges onto either side, and the capacitors charge up and hold the charges on the conducting plates. Once Steve flips the switch, the charges travel through Dave and his chair to neutralize the overall charge of the circuit, giving him an electrodynamic surprise. With the first semester coming to a close, Mr. Belak says that although E&M may seem theoretical, so far, it all has real-world applicability.
Steve and Dave jokingly glance at each other and realize that Mr. Belak doesn't even know the half of it.
He continues to say that after the final, second semester will deal with topics beyond anything you can imagine.